मोशन ऑफ रिजिड बॉडी। आईटी जेई अचीवर बैच 1 के बच्चों के टॉपिक टेस्ट के सवालों की इस कड़ी में एक और छोटा सा इंटरेस्टिंग क्वेश्चन है हमारे पास में। देखते हैं, पूरा क्वेश्चन पढ़ते हैं पहले। ए पार्टिकल ऑफ द मास स्मॉल m इज फिक्स्ड टू वन एंड ऑफ ए लाइट स्प्रिंग हैविंग द स्प्रिंग कांस्टेंट k and the unstressed length of the spring is capital L. Other end is fixed and the system is given an angular speed omega about the fixed end such that it rotates in a circle in gravity free space. Determine the stress in the spring. We are given a spring of the length capital L. A particle of mass small m is attached at the one end of the spring. Second end of the spring is fixed and it is given a angular speed omega for the circular motion. We have to determine during the circular motion what will be the stretching in the length of the spring. It is obvious that when the particle will start circular motion, it will experience a centrifugal force which will act readily outward, and this will stress the spring by somewhat distance, say small x. This distance we have to find out. What is the concept? Simply, during the circular motion, particle must need a centripetal force, and that centripetal force is numerically equal to the centrifugal force. So centrifugal force will be balanced by the spring force. When spring is stressed by some distance, then it will apply a restoring force to regain its shape and size, and this spring force will be equal to centrifugal force. So we have to write down solution. During the circular motion, required centripetal force will be provided by the spring force, and centripetal force equals mr omega square. Say r is the radius. What is the radius of this circular path? L plus x. So we can write the centripetal force m L plus x into omega square. mr omega square centripetal force in term of the angular speed, and spring force equals spring constant k into deformation. Say deformation is x. We have to determine the value of the x. We can find out from this equation. We can write ml omega square equals kx minus mx omega square. Take the common x, you will get k minus m omega square. X equals ml omega square upon k minus m omega square. This is the stretch in the spring during the circular motion of the particle having the mass small m.